Alright, today I want to look at the circumference of a circle, and I want to expand on the knowledge you already have. So I'm starting from the point of view that you've already looked at the circumference of a circle in previous years, and you know there's a nice relationship between a circle's diameter and its circumference, and that is that the circumference would be equal to this fantastic number pi times diameter. Pi d would be one way we could calculate the circumference. Another thing would be the radius of a circle, which is half the diameter. So in other words, two radiuses make up that diameter. So another one would be 2 pi r, with two radiuses being the diameter. So either of those two would be formulas we could use for the circumference of a circle. So I want to extend that now to this concept of a sector and an arc, not a full circle, but part of a circle. So a sector being a fraction of a circle. And so this letter here, this is called theta. It's a Greek letter. It's often used in mathematics to represent the size of an angle. So I'm going to use theta now to represent the size of that angle. So this arc is not the full circle. It's only a fraction of a circle. And the fraction will be represented by theta over 360. And so this arc length, so I'll call the arc L. I'll say L is equal to. And so theta over 360 is what fraction of a circle it is, multiplied by 2 pi r, or times by pi d, whichever is more appropriate. In a sector, it's more than likely going to be 2 pi r, because you're going to be given the radius of the circle. Okay, so I thought we'd have a look at some questions here, some examples, and we'll start off by finding the circumference, and this is something that I would imagine you're quite familiar with. And I don't want to labour this one, I just want to simply make sure we're all on the same page for the working out. So again, finding the circumference, we look at the shape, I've been given the radius, I'll write the formula, c is equal to 2 pi r, and then I'll just say, well, the radius is 8, so I'll write c is 2 times pi times 8, and then I will do the calculation. And I get c is equal to 50.3 to one decimal place when I round off. So what I want to see in your books is 3 lines of working out. Formula, substitution, answer. Include the units. In this case it's meters. Here's some other examples as well that we might look at. So a circle's circumference is 116 millimeters. Find its radius to 2 decimal places. So for this particular one I want to start off, and this time I know the circumference, I want to find the radius. So I want to use this formula. Again, linking circumference and radius. I'm going to say circumference this time is 116 is equal to 2 pi r. And you're probably getting excited now thinking, hey, this looks familiar. Did this last topic? You're right, it's an equation that we need to solve. When we're trying to find r, we actually know what pi is. So we're trying to find out what r is. So to get r on its own, these are connected by multiplication, so I need to divide, doing the inverse operation. So I'll divide by the 2 pi. I can put that in my calculator and come up with an answer. Radius is 18.46 millimeters in this case. Okay. Going down to finding the perimeter of some other shapes as well, so perhaps some more unusual shapes. This time it's a sector of a circle again. It's a large angle in the middle, this time of 220 degrees. Radius is 12 meters. So firstly, the arc length is going to be equal to theta over 360 times 2 pi r. In this case, my arc length is going to be equal to theta is 220 over 360 multiplied by 2 times pi times 12. Now I can put that in my calculator and work it out. And I guess when I report it, I need to make sure I report it the way they want me to. And it says here to 4 significant figures. So when I get to the calculator, I get L is equal to 46.076692225. That's the length of the arc. I want it to 4 significant figures. So significant figures, good time to review it. You start at the first non-zero and start counting. Zeros in the middle do count. So that would be those 4 there. The next number's bigger than 5. I'm going to round that up to 8. So I've got my length as 46.08, but then I also have for my perimeter these two sides here, 12 plus another 12, and that completes the entire outside boundary of the shape. So I get 70.08 to 4 significant figures. Okay. Another shape, asked to find the perimeter of this shape as well. So here I've got this strange looking shape. It's two straight lines, a semicircle, and then a semicircle coming in. So realistically the shape's perimeter consists of both the straight lines, which are both 25, and also it consists of one semicircle, two semicircles. Both the semicircles are the same radius, diameter, so really the two semicircles I can consider as one circle, so plus a pi d. So that's going to give me 50 plus pi times 18, given that's the diameter of the circle. Said those two together make one full circle, and then when I calculate that, I get 106.5 to 4 significant figures again. 1, 2, 3, 4, zeros in the centre, in the middle of the number counts. So there's some work for you on circumference.